death of stars. In the vast expanse of the cosmos, stars are born, they shine, and, like all living things, they eventually die. But their deaths are not like ours. They are cosmic transformations, reshaping matter and energy in ways that defy imagination. Stars come in all shapes and sizes, but they're not all born equal. The mass of a star determines its fate. Stars can be anywhere from about 80 times the mass of our Sun, all the way down to about 12 times the mass of Jupiter. Our Sun is a medium-sized star. So let's use it as an example. For billions of years, it burns hydrogen in its core, a delicate balance between gravity pulling inward and nuclear fusion pushing outward. This balance is the heartbeat of a star. But nothing lasts forever. When the hydrogen fuel begins to run out, the star can no longer hold itself steady. Its core contracts, while its outer layers expand. The star swells into a red giant, a bloated, dying version of its former self. It would be so huge that the Sun would swallow the Earth whole. As the red giant begins to collapse in on itself, the Sun's core becomes extremely hot and dense. It's so hot and dense that it forces the Sun's outer layers out into space. This forms a beautiful cloud of gas and dust called a planetary nebula. But don't be fooled by the name. There are no planets in this nebula. It's just a remnant of the star's atmosphere. As the collapse continues, the core gets hotter and denser, reaching 100,000 degrees Celsius. At this point, the core is small enough to be considered a white dwarf. It no longer generates energy, but instead radiates only the fading heat of its former life. Roughly the size of Earth, yet with a mass comparable to that of the Sun, a white dwarf is the dense, smoldering ember of a once great star. White dwarfs are also very hot, but they aren't massive enough for nuclear fusion to continue. They're just dead stars. Our white dwarf will continue to cool over billions of years until it turns into a black dwarf. A black dwarf is a white dwarf that has cooled so much that it stops emitting light. Black dwarfs are extremely rare, if they exist at all. That's because it takes trillions of years for a white dwarf to cool enough to stop emitting light. As far as we know, the universe isn't old enough to have created any black dwarfs yet. But in the distant future, when galaxies have aged and stars have burned out, the universe will be filled with these dark remnants, silent witnesses to a universe that once glowed with light. Stars are not eternal, but in their death, they write the story of the universe.